afternoon, everyone. Thank you for joining us today. My name is Carlos Agbini. I've been a project engineer at PIMSoft for 4 years, and I'm here to share with you some advanced analytics that you can do with your Sigmafine system. How can we get more value out of our Sigmafine system? What sorts of questions can these advanced analytics help us answer? Maybe you're an oil and gas company. You have your total production numbers, but you're interested in back allocating those production numbers into individual oil well performance. Or maybe those wells are owned by different shareholders. Maybe you're a pharmaceutical company that's looking to better estimate the true cost of a production batch. Or maybe you're a metal and mining company interested in better estimating the valuable metal content in your ore. During this presentation, we're going to look at how these advanced analytics can help us answer some of these questions. So the advanced analytics we're going to focus on today are composition tracking, which will track your composition, as the name states, from your feed and your raw materials down to your final pipelines and your final products. And we're going to also look at component balance, which is a reconciliation analysis that is essentially balancing both the overall mass and the mass of the individual components. So we'll take a look at composition tracking first. So just a little demo here to show you basically how it works. Imagine you have 2 storage tanks with 2 different types of crude in them, different compositions, and we have a simultaneous movement out of these storage tanks into a feed that goes into a process unit, let's say. So composition tracking is going to allow us to see not just the overall mass, which you'll be getting from your mass balance, but the composition of the feed that is going into the process unit. Composition tracking applies different mixing models depending on your application. The most common mixing model is the well mix model, which is common for liquid tanks. We also have the first in, first out mixing model, which is pretty standard for pipelines. And we have the last in, first out model, which is common for stockpiles and other solids. So here we have an example of a Canadian refinery that is using composition tracking to track the composition of their crude on a daily basis. And these totals are aggregated into monthly composition totals. So going back to the back allocation example that we posed earlier, let's say you have 3 wells that are in production. They are producing gas, oil, some water reinjection. So composition tracking is going to allow us to not only see the total production numbers, but the individual well performance. And an even more creative application of composition tracking, let's say that the wells have different ownership, different shareholders. So we're able to back allocate those final production numbers and see what percentages of that final production belongs to which shareholders. So looking at a pharmaceutical example, let's say you're taking in 20 to 30 raw materials. They get stored in tanks, go through sterilization, mixed. So we all know that no process is 100% efficient. Maybe the sterilization cycle doesn't perform as expected, or maybe the final products don't meet the quality standards. So some of those raw materials end up as loss. So how is composition tracking going to help us better estimate the true cost of your batch production? Well, with composition tracking, we're going to be able to see what percentage of those raw materials actually made it to the final products, and what percentage of those raw materials were lost to waste, allowing us to get a better estimate of the true cost of our batch production. We're going to take a look at some examples of component balance now. So component balance is a reconciliation analysis that is going to apply certain constraints. The first constraint is your classic mass in, mass out constraint. The second constraint that's applied is the same mass balance, but applied to the individual components. And the third constraint is an optional one, basically that the mass fraction of all the components is equal to 1. This is an optional constraint because sometimes you're not interested in balancing all the components. For example, in metals and mining application, we might be interested in just a subset of components, maybe just balance your gold or your copper. An interesting example of component balance, maybe you're not interested in balancing specific components, but instead you're interested in balancing the phases, a gas phase, liquid phase. So you're able to do this, and what's interesting about this example is, your multi-phase flow meters, they're more expensive, they are less reliable than, let's say, a meter that's just measuring one phase. So this is the beauty of Sigmafine here, that we're able to, as we discussed in previous presentations, you're able to assign a tolerance based on your confidence in the measurement of those meters. So Sigmafine is able to take in all these measurements, exploit the redundancy in the measurements, and give you a clearer picture of the different phases in different parts of the model. So this allows you to validate the data that's coming in from meters, which is important. And this can be run in near real time. So here we have an example of basically this dashboard was created using PyVision, and they're doing exactly that, validating the measured versus the reconciled values that are coming in. So we see here in the gas pipeline export, there's a pretty large discrepancy in the reconciled versus the measured amount. So this would lead us to investigate further. We're able to bring in some additional analytics, and we can see here from this example, this dashboard was also created using PyVision. We can see that there's big discrepancy in the gas-oil ratio, the mass fraction. We have different quality indicators here that are showing red, meaning that something needs to be done, some action needs to be taken. And this is what makes Sigmafine so powerful, is we're able to see these issues with meters and address them. The next example we're going to take a look at is a grinding and flotation circuit. So one of the main challenges in this sort of application is the reliability of the measurements. Sometimes you have them, sometimes you don't. Maybe they're not so reliable. So Sigmafine is able to take in the inputs that we do have, whether they be flows or information from the analyzers, and take this all in as inputs and give us a clearer picture of the different compositions in different parts of the model. After applying the component balance, we can see here from this bar chart, we have our metal recovery, and we can see that after applying the component balance, we have been able to reduce the uncertainty in our measurements. This is allowing us to provide more reliable and consistent metal content and recovery yields. And it's going to allow us also to estimate the compositions in areas of the model where maybe we don't have measurements or maybe we're not sure. Sigmafine is also consistent with the AMIR code for metal accounting. And this is also going to help us improve our water balance. How much fresh water are we consuming? How much wastewater we're producing? It's all auditable by environmental authorities, so very important information to have. So to recap a little bit the different examples that we looked at oil field monitoring, detecting anomalies in the measurements. This analysis can be run near real time, hourly, whatever your application needs. We looked at the back allocation example, looking back at individual well performance or wells that are owned by different shareholders. We looked at the batch cost allocation problem where we were able to, with composition tracking, better estimate the true cost of our production batch. And this can be run hourly, daily, for the duration of your batch process, whatever application we need. We talked about material tracking the compositions from the feeds and raw materials to the final products. And we looked at the metal accounting example where we were able to better estimate the metal content in our ores. So to recap a little bit, we have over the advanced analytics that we discussed, we have the component balance that is taking in values from your analyzers. It is a data reconciliation analysis, and the inputs and the outputs are in the form of data tables within our Pi asset framework. Everything is configurable at the asset level, of course. We also looked at composition tracking, which is tracking the different composition from your feed down to the final pipelines. And the types of data that we're using can be values or strings, maybe it's material, maybe it's ownership. And these inputs and outputs are also in the form of data tables in your Pi asset framework. And also, these are all configurable at the asset level. Thank you guys for your attention. Welcome any questions.